Okay, whether I talk to you in class or whether this is what you get from me today, we're going to talk about isotopes, which we touched on when we talked about Dalton. Remember from your quiz that Dalton is the one that discovered an atom, and he made up what we still know today as the atomic theory, Dalton's atomic theory. And he said some things in his atomic theory, and one of the things he said was that atoms of the same element are exactly identical. And most of what he said, we still hold true today. But that one thing is not. I can't talk and write at the same time. He said that if an atom is of the same element, it is exactly identical to every other atom of that same element. For example, every atom of, say, nitrogen is exactly like every other atom of nitrogen. And we now know that that is not true, that every atom of nitrogen has exactly 7 atoms. And we talked about that the other day because we talked about the 3 particles in an atom, protons, electrons, and neutrons. And I told you and I expected you to know that the protons in an atom are what identify that element, and the electrons are what give it its character, and the neutrons are like the policemen, and it's their job to keep the protons in and keep the electrons out. We talked specifically about that. Okay, but you can have nitrogen as long as it has 7 protons. If it has more or less neutrons, it's still nitrogen. If it has more or less electrons, it's still nitrogen. But it's only nitrogen if it has exactly 7 protons. So Dalton's atomic theory has a couple of flaws, but it still overall holds true today. What we call atoms of the same element, atoms of the same element that have different numbers oh my gosh, look at how I spelled different. Different. D-I-F-F-E-R-E-N. Different numbers of neutrons are called isotopes. Isotopes. Okay? Now remember, they have to have the same protons. They just have different neutrons. Why would they have to have different neutrons? Because the protons are not well behaved, or because the electrons are extra feisty. Really, scientifically wise, it's not well understood why the exact mix of protons and neutrons isn't stable. We're thankful that it is because we use it in medicine a lot. They use it to track cancer cells in radiation. For if any of you know of anyone who's ever had to have a tracer for, say, maybe a thyroid tumor, or to track perhaps something that's going wrong with their colon or something along those lines, then they can use it for tracking what's going on inside. If they've ever had barium, had to drink that orange barium stuff and then go take an x-ray, they're tracking it, they're finding what it is. So we use it in medicine quite a lot, actually. And these are radioactive isotopes, so when we think of radioactivity, it doesn't always make the Ninja Turtles. We use it for good. All right, now let's show you how to differentiate between isotopes. We've been talking about nitrogen, so let's continue talking about nitrogen. How do you tell one nitrogen atom or isotope from another? We use what's called the atomic number. The atomic number is very important because it tells how many protons. Remember, it's the protons that tell what atom it is. So for nitrogen, since nitrogen has exactly 7 protons, that's what makes it nitrogen, its atomic number is 7. So for nitrogen, its symbol is an N, and if you look upon the periodic table, you're going to find the letter N, big capital N, And you're going to see in the top right corner of this particular chart that's in our classroom, there in the top right corner, there's a big number, whole number 7. That means it has 7 protons. But now, when you write an isotopic, that's what it's called, an isotopic or topic, potato, symbol, you write the atomic number goes in the bottom left corner. So I'm going to write the atomic number of nitrogen, which is 7. And then in the top corner, right above it, goes the mass number. Now the mass number tells how many things live in the nucleus. Okay? And what all lives in the nucleus? Protons plus neutrons. So it tells you protons plus neutrons, since that's what lives in the nucleus. And so that's how you can tell the difference between the different kinds of, in this case, nitrogen. Because I can write a 14 up top, and this is nitrogen 14. Okay, so let me go to a new screen. So if I wrote 14,7N, this is called nitrogen 14. And we would see that this one has 7 protons because of this number 7 and this number 7 go hand in hand. Okay, now to find the number of neutrons, we're going to say 14 minus 7 equals 7 neutrons. That comes from this 14 or this 14 up top, and we subtract. That is how you find the number of neutrons. You subtract the mass number minus the atomic number to find the number of neutrons. And this number behind the name is the mass number, and it is used to distinguish the different isotopes. So if I go to another new screen here, and I wrote nitrogen, which is another isotope of nitrogen, nitrogen-15, then this nitrogen has an extra neutron in there, you see. It has still got 7, so I write N, 7 on the bottom, because every single solitary isotope of nitrogen must have 7 protons. But this one has an extra neutron in there. So it has 7 protons, but it has 15 minus 7, or 8 neutrons. Well, what about the electrons? In neutral atoms, every single neutral atom, the protons will be equal to the electrons, always, for neutral atoms. That's the only way they can be neutral. And that's the only way they can be called atoms. Every atom is going to be neutral. All right, I hope you get this, because you're about to have to do a chart that you're going to, here's what you're going to have to do real quick. I'm going to show you. I'm going to give you this symbol. You're going to have to fill out, you're going to have to fill out the rest. You're going to have to fill out the atomic number, the mass number, the number of protons, the number of electrons, the number of neutrons, and the isotopic name, or the name. And when I say name, I want you to write the entire name. So for the example that we just did, if I wrote 15,7N, I want you to say the atomic number is 7, the mass number is 15, the number of protons is 7, the number of electrons is 7. These two will always, not forever, for atoms, neutral atoms, they will forever be the same. Now, next chapter we're going to get to where they're not the same anymore, but for now they are. And then to get the number of neutrons, you always subtract 15 minus 7 is 8. And then this name, you're going to have to write it correctly, because if you leave off the last part of that name, I'm going to say minus 1. This is nitrogen 15, because that 15 is part of its isotopic name. Okay, please notice on here you have 1, 2, 3 boxes that are going to be the same. Alright, now I'm going to fill in various different boxes on here, and you're going to have to fill in the rest. I hope you got that, and I hope you have a good day.